All right, here's the multiple choice section. Um, the first question is asking um, how negatively charged objects are affected by other objects. And so I'm just going to use kind of the process of elimination here to get rid of all the wrong answers and hopefully get the correct answer at the end. Um, Negatively charged objects will always attract other negatively charged objects. And so that's false because we know opposites attract and like charges repel. So that one is not correct. Um, Negatively charged objects will always repel positively charged objects. Well, they attract opposites, so negative and positives are opposites, so that isn't true. Attract neutrally charged objects, and that one is true. Neutrally charged objects are attracted to any type of charge because it polarizes itself within the material, and there should be an attraction force as a result of that. So that's the answer for number one. Number two, which of the following statements is true about polarization? Polarization is a way of charging an object, and that is actually false. We like to talk about polarization as separating a charge. So if we had four positive charges, let's say we had two positive charges on the left side, we would want two negative charges over here. But if you were to count the net charge, you'd have a charge of 0. So we don't actually charge through polarization, we separate the charges. Polarization happens when a charged object touches. If it's touching an object, that the key is here, it's not polarization, because let's say I had a negatively charged PVC pipe and I touched this to my object, and one of these charges actually jumps. Here, I'm going to touch it, and one of my negative charges jumps over here. That's not polarization because we actually gave it a charge. Now, if you take a look at the object, it has more negatives than positives, so we would just call that charging it. So that one would be false also. So that one's not true. Polarization separates charged and neutrally charged object. That's what I said. You don't want to charge it, you want to separate the charges. So that one is the correct answer. So we would want to fill that bubble in there. All right, the third one. The further two charges are from each other, the stronger the electrical force is on the charges, and that is actually false. You should have seen this in the tape lab when we charged two objects. The closer you put them together, the more they were attracted or repelled by each other. Therefore, this one right here is the correct answer. The weaker the electric force is on the charges. So the closer you have them together, the stronger. The farther away they are, the weaker. And that is the multiple choice section. Hopefully that helped you a little bit.